hand it off to two very capable AP Bio students in 11th grade, Emmett Hirschhoffman and Kiki Levin.
Hello, everyone. For the next 40 minutes, we will be in conversation with Dr. Naor Bar-Zeev. He will be answering a few questions on his experiences in the development and distribution of vaccines globally and on the COVID-19 vaccine specifically. Later in the program, the chat will be open to questions from students and faculty regarding Dr. Bar-Zeev's professional experiences and the COVID-19 pandemic.
Dr. Naor Bar-Zeev is an Associate Professor of International Health and Vaccine Science and Deputy Director of the International Vaccine Access Center at the Johns Hopkins Bloomberg School of Public Health. He is a pediatric infectious disease physician and statistical epidemiologist. His focus is on understanding how to maximize the benefit of existing and future vaccines in low-resource, high-mortality settings, how best to protect vulnerable groups like newborns and pregnant women, and how to optimize methods of evaluating vaccine impact and effectiveness. He is a co-principal investigator on a Bill and Melinda Gates Foundation that funded 7 country randomized clinical trials sponsored by the World Health Organization for treatment of childhood diarrhea, as well as for a novel neonatal rotavirus vaccine. He is undertaking typhoid cost of illness studies with colleagues internationally and is a founding member of the Immunizing Pregnant Women and Infants Network. Dr. Bar-Zeev is also a member of the PATH-led Advancing Maternal Immunization Collaboration. Previously, Dr. Bar-Zeev led the Vaccines Research Group at the Malawi Liverpool Wellcome Trust Clinical Research Program and was a member of the Malawi National Immunization Technical Advisory Group. He established the Wellcome Trust-funded multi-site national vaccine surveillance program in Malawi as well. He also worked as a pediatric infectious disease specialist at Queen Elizabeth Central Hospital, where he continues clinical practice on a visiting basis.
Dr. Bar-Zeev is a fellow of the Royal Australasian College of Physicians, dual certified in general pediatrics and infectious diseases, the Australasian College of Tropical Medicine, the Royal Statistical Society, and an accredited statistician with the Statistical Society of Australia. He has 20 years experience in global child health across East Asia, the Pacific, and Africa, and has worked with the World Health Organization, UNICEF, and Save the Children. He has received funding from the Gates Foundation, PATH, CDC, and the National Institute of Health. Thank you for joining us today. We are honored to have you with us. Now we'll pose the questions. Can you tell us about your role as an infectious disease physician and epidemiologist in providing vaccines in Africa and why this work was meaningful for you?
Sure. So we spent about 7 years living in Malawi. Yona went there when he was a little boy, grew up there. Most of my work there was around the introduction of 2 important vaccines for childhood diseases. The first was for a disease called pneumonia, which is an infection of the lungs and is the most important cause of global child mortality. And the second was for a disease called rotavirus, which is a disease that causes diarrheal disease, also a very important cause of child mortality. So by the introduction of these 2 vaccines, Malawi was able to drastically reduce child mortality and improve life expectancy and improve quality of life and so on. So my role was to advise the Malawian government on planning for the introduction and then on the national evaluation of that impact on mortality and on morbidity, in other words, on death and on disease. And also to evaluate the cost effectiveness of those interventions, because every decision comes with cost. It has to be, you have to spend money, and so you have to understand how much money to spend. And it's particularly important in low-income countries because a cost of a vaccine could really break a budget or be unaffordable for a country. So you need to be able to say, well, what's the economic benefit for that country, and how then can they best negotiate a price with the providers? So those things are important in the United States just as much as they are for a poor country like Malawi. And in addition, I also worked clinically as a physician for children, and my particular area was in pediatric tuberculosis and pediatric HIV. And I worked with adolescents who had been born with HIV and who lived their whole life on drugs for HIV, often already on 2nd and 3rd line drugs. They often had lost their parents and were themselves the heads of households at your age, Emmett and Kiki. They were children who were raising their siblings because their parents had passed away from HIV. And so a really remarkable group of young people who had the world's responsibilities on their shoulders and making critical decisions about going to the workforce, staying at school, managing their well-being, health-wise, and in other aspects of life that, as you might imagine, are impacted also by HIV. So these, were really inspiring kids, and that was really, all of that put together was a really wonderful and meaningful experience for all of us as a family.
Wow, that's really beautiful. What is your role in the development and distribution of the COVID-19 vaccine?
So we've been working at Johns Hopkins on a lot of different aspects of COVID-19 vaccine development. Clearly, everybody's world turned around when the pandemic burst onto the world's stage, really, and that included our professional work. Prior to that, we had been working on a lot of other vaccine access issues, and in particularly also advancing adult immunization, which clearly was kind of fortuitous because this is really, by and large, an adult vaccine program. But my personal role was to review the science in early vaccine phase development. So I reviewed much of the science around the phase 1 and phase 2 trials of particularly of the adenovirus vectored vaccines, both for the Oxford one, the AstraZeneca one, the Chinese one, the Russian one, and also had some input onto the mRNA vaccines as well. And apart from the vaccine development side, we were working very closely with the World Health Organization to support global distribution and procurement and planning for countries, because it's a massive undertaking. And so thinking through all of what is required to really roll out the vaccine, what happens the day after a vaccine, which we're now in really, and we can see how difficult it is to achieve rapid coverage. So in the United States, so you might imagine that in other countries there are lots of challenges also. So planning for that as well. And also dealing a lot with behavioral sciences and vaccine hesitancy and safety, and addressing people's very legitimate concerns around vaccines and their worries about things moving so fast. So really addressing that at a community level, and locally in the United States also supporting the Jewish community, and particularly Poskim and others in coming to a better scientific understanding underlying the vaccine, which comes to bear weight on their halachic decision making as well.
Do you know when teenagers, like the SAR high school students, will get the vaccine, along with which vaccine they will get? And when younger children, for example, the ones at SAR Academy, would get the vaccine?
Yeah, so I'm going to give you a long answer to that question. The short answer is that not for a while. It'll probably be some months before that happens, and it's going to go down backwards in age. So at the moment, the Moderna vaccine is licensed under emergency licensure only down to 18 years of age, the Pfizer down to 16. So some of you out there would be eligible potentially for the Pfizer vaccine. But as we have increasing more evidence around vaccine safety, and we now know that the vaccine's been given in millions of doses around the world now, and as time goes by, we will see ongoing reports of safety, and some adverse events will be reported as well. The more confident we are that the vaccine is safe in adults, then we move towards more vulnerable groups, so-called vulnerable groups. And one of those groups that we tend to not jump into straight away are children. We want to demonstrate that the vaccine is safe and efficacious in adults. And once we demonstrate safety, then we go to children. So now trials are underway with children down to the age of 12, and we'll probably see results of that fairly soon. And then after that, there'll probably be further trials down to the age of 5. Whether or not there are vaccine trials that go below that may or may not occur. Clearly, though, this is an unusual circumstance, because most vaccines that we tend to think of vaccines are childhood vaccines. So for many vaccines, we do establish the trials in children, we use them in children. And if anything, the question is, can we or should we go up in age, not down in age? But here we're really primarily targeting older adults and adults that live with other medical conditions that put them at risk for bad outcomes from COVID-19 disease. But there is an important issue here, and that is that it's really young people, particularly sort of 15 and above into the 20s, into the early 30s, that are driving transmission of COVID-19 in the community. So even though they themselves are at relatively low risk of having bad, hospitalization, let's say, or death, whatever, those outcomes are quite rare in young people and very rare in very young people. But certainly in the young adults and in adolescents, there is transmission, asymptomatic, that means without symptoms. So there's a good reason to vaccinate that group, because we want to reduce transmission. The difficulty is that until now, the vaccine trials that have been run have been designed to evaluate the vaccine's efficacy against disease. I think biologically, it's important to understand that we live in a world that's full of germs. Our skin, our mouth, our eyes, our nose. We carry bacteria, and sometimes we carry viruses all the time. Sometimes those viruses or bacteria enter parts of our body that they shouldn't, and we call that infection. And sometimes we don't even know that that happens, and that's asymptomatic infection. And sometimes we get sick from that because the immune response is vigorously fighting that infection, or the infection itself is causing harm, and we call those symptoms disease. So there's a fundamental difference between infection and disease. And we know that with COVID, a fairly large proportion of people, maybe even a large minority, and maybe in some cases a majority of people can have asymptomatic infection, particularly as you get younger in age. The majority will be mildly symptomatic or asymptomatic. So if the vaccine is designed to target symptomatic disease and it also reduces infection and transmission, that's wonderful. But if it doesn't reduce transmission or it doesn't reduce infection, but it protects us from disease, that's also wonderful. That's also really good. But it will mean that the way that we use the vaccine will be very different, okay? And I want to explain what that means. Imagine that everybody gets vaccinated and they think, oh, great, I'm not going to get sick, so they stop wearing their mask, they stop social distancing. Transmission is not affected, let's say, by this vaccine, then transmission could go up, right? And if transmission goes up and the vaccine works less well in the elderly or large groups in the community that are dealing anyway with issues of social justice or trust of government, like the African American community, where there may be more hesitancy than in other communities, for example, if their uptake of vaccine in those communities is less, and if COVID outcomes we know in communities of color are worse, then you could end up with an increase in equity, an increase in justice, and a worsening of outcomes. So in other words, it's really, really important to know whether these vaccines not only reduce disease, which is really important that they do, but that they also reduce transmission. And if they do reduce transmission, then yes, we should rush to give it to young people. If they don't reduce transmission, then we should absolutely make sure that we cover absolutely everybody who's at risk in any risk group, and work very hard with communities who themselves may be more hesitant than other communities, including the Haredi community, other groups. So if we do, so really the biology really determines the policy. And so the timing of when younger people should be vaccinated really depends on what the vaccine does. If the vaccine reduces transmission, I'd get you all to line up now and give it to you virtually through like that. But if it doesn't reduce transmission, then we can afford to wait a little bit. The other thing to think about briefly is that children are in contact with adults, whether it's your parents or your grandparents, or your teachers for that matter. And so it's really important that in congregate settings, in settings where you guys all get together, like in school, that the adults around you are protected. That's going to be really important as well, at least initially. And then eventually you guys also, we would hope to be able to vaccinate everybody. That's a long answer.
A number of SAR students have recently had COVID-19, yet current medical advice is that they should still possibly get the vaccine. If this is the case, can you explain to the students why even those who have had COVID should still get the vaccine?
Yeah, so I mean, if you've done sort of study skills and you're going over your work, you know that you're supposed to study the material, but then you're supposed to revise the material as well. And we know from our tradition that you can't compare somebody who's revised 100 times to somebody who's revised 101 times, right? So the more times, the same is true for the immune system, the more times the immune system encounters a pathogen, an organism that causes disease, the more well prepared is the immune system to fight that pathogen. And so in most instances in nature, it's not, we mount an immune response on first receiving an infection or first feeling sick, but we really mount a very long-term immune response on seeing it again a second or a third time. Sometimes it's asymptomatic on the third or second or third exposure, but we still see it. But with COVID, we don't want that to happen. We don't want people to have COVID again before they mount a long-term immune response. So if they've had COVID once, there's not a lot of evidence to suggest yet that they have lifelong infection. Clearly, we can't have that evidence because we've only had a year since COVID, so you can't say what things will be like in 10 years. But from work on previous coronaviruses, there have been 2 emergences of very severe coronaviruses in the 21st century, and there are also endemic coronaviruses that have been around for a long time in humans. We know that the immunity against coronavirus itself is not lifelong. It wanes after maybe 3 years, 5 years, and in some cases less. And we know that antibodies, in this case of COVID-19, seem to go down. They wane after about 3 or 4 months. So in other words, if somebody, let's say, had COVID in the first wave, in the first peak when your school shut down, right? It could be that by now they're not as protected as they were initially. Or it could be that even if they are still protected, by giving them a vaccine, they can really generate a long-term immune response. So there are good reasons to think that we should be giving vaccines even to people who've had COVID in the recent past, and certainly in the more distant past.
The Moderna and Pfizer vaccines inject a piece of the virus's mRNA into our body cells to get them to make corona protein, which would cause our white blood cells to produce antibodies against the protein if later exposed to the whole virus. There has never been an mRNA vaccine that has been approved nor used before now. Can you explain why not? And why are these ones considered safe?
So I just want to correct the tiny detail, which, it's not very important, but I think relevant still, is that we're not injecting any part of the virus in this vaccine, not the mRNA, not anything else. Doesn't come from the virus. It's chemically made to mimic the mRNA of the virus. So in other words, as you know, mRNA, or I should say RNA and DNA, are genetic code, and they're made up of 4 base pairs, A, C, T, and G. And if I know the code, like if I know how to spell Emmett, Hershoff, Hoffman, or whatever your name is, then I can write out the letters of your name, right? And if I know how to spell out the RNA in the virus, which we knew very quickly after the first few cases, the Chinese scientists made public the genetic code of the virus very quickly, then immediately we can start to generate chemically, not biologically, but chemically to copy those, put those letters together, those A, C, T, and G's together, and then that becomes the blueprint, right? It's the Kelba Oraita Ubara Alma. It's like that, right? HaKadosh Baruch Hu looked at the Torah and then he created the world. We look at the code, the genetic code of the virus, and then the body examines that code and then makes the protein, as you've said. So the detail is that it's not the virus RNA, it's just the RNA that's the same as the virus RNA. But in any case, RNA is a half of that double helix, the ladder that's twisted. DNA, the picture of DNA, it looks like a ladder that's twisted on itself long ways. That's DNA. And that's a very stable molecule because it's got 2 backbones and the rungs are very strongly bonded to one another. But RNA is 1/2 of that rung. Imagine taking a pair of large scissors and snipping a ladder along the rungs. Okay, so you've got 2 half strands. Inherently, that's a very unstable molecule. And one of the good things and the bad things is, the good thing is that the body gets rid of it very fast and recycles the base pairs. So it doesn't hang around in the body after it's had its effect, which argues towards its safety. But the disadvantage is it's really hard to make it stable enough to deliver from the factory to the delivery site. It has to go in very, very ultra cold transport. And even from the needle into the muscle, it degrades so quickly that there's been challenges in the past 20 years in research to make it stable enough that it generates a sufficient response. And the way they got around that is to make a kind of a lipid envelope around it, a little fat envelope around it, a bubble of fat or a bubble of soap, if you like, really, into which the RNA is placed. And then that survives as it gets into the muscle enough to get into the cell and produce that response. So that was the answer to the first part of the question. I think the second part of your question was asking me about other forms of vaccines, like killed vaccines or live vaccines. Is that right? Or I've lost my train of thought now because
it was more regarding the safety of the virus, but I feel like you already.
Sure. Yeah, look, so the safety, let me talk then specifically about safety. So yeah, biologically, I think inherently RNA vaccines are reassuring in that way. But I think it's really important that we don't, when you lose your keys in the dark, you don't go to the nearest light post and look for your keys there just because that's where there's light. That's not where your keys are going to be, okay? So if we're used to seeing things and used to expecting certain things, and all we look out for is the things that we expect, then we're not going to see the things that are unexpected. And we have to be really humble about what we don't know. And in science, as in all things, the things that we don't know are infinitely more than the things that we do know. And yes, we've learned a massive amount in 1 year, and 400 scientific papers a week come out about COVID, and we're learning very fast. But clearly there's a lot to be learned still. And that's really important because even though I'm saying here that RNA vaccines inherently are safe by design, it doesn't mean that they are safe. It just means that we think they'll be safe. And it's really important that we retain an open mind and listen to concerns and establish systems to detect unexpected events and to be able to tell the community just how safe or unsafe these vaccines are. And so that's one of the reasons why the trials that happened were very large-scale trials, larger than they needed to be for efficacy, because we wanted to be able to demonstrate safety. At least that's part of the reason why they were very large trials. And now we know that the vaccine, at least in the United States, have been given to over 4 million people. We had hoped 20 million by now, but 4 million have received it, plus many others around the world. So we've got millions of examples of the vaccine being given, and at least in the short term, out to about 4 to 6 months, if you go back to the very earliest part of the trials, we know that these vaccines are safe. But we need to maintain surveillance for safety, because there have been cases in the past where very good vaccines that were very efficacious and were considered to be safe were found after licensure to be unsafe and were withdrawn and were taken back. And whenever that happens, that is a really ethically difficult decision to do, because a vaccine safety is not an absolute thing. The safety of a vaccine has to be weighed up against the safety of not vaccinating. So to give you an example, let's say an old rotavirus vaccine called RotaShield vaccine was approved in 1996. It was found to cause 5 cases of intussusception. Intussusception is when the small bowel, which normally has this process called peristalsis, where the muscles of the bowel squeeze in linear timing to push food along, okay, that it caused a problem where the small bowel telescoped on itself, okay, and that causes an obstruction of the bowel, and it made some kids really sick, and it also caused the death of 2 kids, I think maybe even 3 kids in the United States. As a result of that, that vaccine was withdrawn, and there were no vaccines for rotavirus for another 10 years. But in those intervening 10 years, hundreds of thousands of children in other settings died of diarrheal disease that could have been prevented by this vaccine. So there always is a question of what risk is a society willing to take? What's the benefit of vaccination versus what's the risk of vaccination? And that risk-benefit ratio was in favor of removal of that vaccine in the United States, because very few children die of diarrhea in the United States. But it may not apply in other settings. But if you then go to another setting and you give them a vaccine that you wouldn't give in the US, then you'd be accused of a double standard. So there's lots of issues here and lots of debate, and very valuable and important debate, over which I'm not an expert, because I'm not an ethicist and I'm just another person. So my opinion is just as important as your opinion. But the debate needs to be informed by good science. So bottom line, anytime you're thinking about safety, you've got to think about the safety in the two sides. That's the risk of taking the vaccine and the risk of not taking the vaccine. And so clearly for your grandparents, that benefit is far and away in favor of receiving the vaccine. And in the case of you kids, or young people, it's probably still in favor of receiving the vaccine, but the balance has to be established more rigorously, which is why you're not receiving it yet. So, these are really complex questions. They're interesting questions. They raise ethical questions. They're not just about the science, and they raise a meta-scientific issue, a beyond science issue, that science produces tools. But the way we use those tools, right, is an ethical question and a social justice question. And so, the motto of Pfizer is science will win. But that's not really true. Humanity will win if we know how to use the science properly. Okay, so science provides tools, and those tools can be misused, and they can increase inequity even when they're used well intended. So very important to get our ethics right and our social discourse right, and not just the science. That's it for that.
Okay, final question before we go to the questions from the audience. So we know that a mutant variety of the virus that originally appeared in the UK is now in the US and is more contagious than the original strain. How do you think the COVID pandemic will be affected by the mutant variety of viruses that appear? And what role will the new mutations have on the effectiveness of the current vaccines being given?
So the fact that there are mutant or differences, mutant makes it sound like they're some kind of, they crawl out of the sewer and they look all weird. They're just differences genetically, and that doesn't mean that they're very meaningful. For example, all the people on this call are genetically different to one another, but we're still all the same species, and we still all pretty much function in the same way. Some of us have blue eyes, some have brown eyes, some have green eyes. It's a little bit the same with any population, biological population. There will be differences. The question is, do those differences confer an advantage for the virus, or is it just an emergence of another cousin, another whatever? Okay. So at the moment, we're seeing that this new strain seems to be dominating new cases. And so there's a suspicion that it might be transmitting faster. There's no direct evidence of that. There's a suspicion that it might be transmitting faster. There's no evidence that it makes you sicker. There's no suggestion that vaccines wouldn't work against it. but it's transmitting faster. Is that relevant? Well, it is relevant because we know how hard it is to contain this pandemic, even with all of the social distancing. And so if there's a vaccine that transmits more readily, then it'll make it even more difficult to control. And in an indirect way, that will lead to more cases. And in an indirect way, that'll lead to more hospital beds being taken up. And so therefore, potentially not having enough ventilators for people, and thus increasing the mortality. What we call reducing the curve or flattening the curve will be more difficult. But that's yet to be demonstrated for sure. So the best thing that we can do is get this vaccine up and running and the programs available to as many people as possible, as quickly as possible. And the debate at the moment around that is whether to give more people a single dose and wait for a while before we get the second dose, or to reserve the second dose and give each individual person vaccinated the 2 doses. And it's an interesting question. Would you rather achieve lower efficacy for more people, or high efficacy for the few that you give them? It's, again, a very interesting debate ethically as well as scientifically. I'll leave it for, beyond this discussion. Yep. Next question. Thanks.
All right. Thank you, Kiki and Emmett, for those questions. I've gotten a number of questions from the audience. I'm going to try to pare them down a little bit. First of all, I do want to say, a tremendous thank you. We have about 11 minutes left in this period. I want to thank you, Dr. BarZeev. This has been incredibly enlightening and just like really wonderful to hear your wisdom and along with your humility. One of the questions actually was just the question you just addressed now was about the, giving more people 1 dose or getting 2. I hear that, so I'm not going to go with that. I think you talked about that a little bit. One of the questions people ask, actually, I'm going to say 2 questions at once, both kind of risk questions. Talk a little bit about, we have kids who in our school who have anaphylaxis with various allergies. To what extent should they be concerned about when it gets their turn to take the vaccine? To what extent are people who have anaphylaxis, should they be concerned about it? And also, are there any concerns about women's health and reproduction, fertility issues? Another question that was asked. You can
yeah, so I mean, I'm not going to do justice to the questions because of lack of time, but fundamentally, severe allergy can occur pretty much to any exposure, but it is a very rare event. We have had a few cases of severe allergy following the Pfizer vaccine, but we've not seen, we've now given millions of doses of that vaccine around the world, and we've not seen a major epidemic of anaphylaxis or severe allergy. I think anybody who has had known allergy or carries an EpiPen or any of those types of things should be, needs to be cautious and probably needs to be vaccinated in the context of, sufficient medical support in case they have an anaphylaxis. But it's important to say that at least these mRNA vaccines that are currently available in the United States are produced chemically, they're not produced biologically, so they don't contain many of the allergens that trigger anaphylaxis in most people that have allergy. And certainly if anybody has more mild allergies, food allergies or other things, that's by no means is it a contraindication. That means that you would still need to get the vaccine. And in fact, even if you had very life-threatening anaphylaxis, you still can get the vaccine. You just need to get it under supervision. It's really only if you know that you have allergy to the products in the vaccine. That's the only absolute argument against it. And there's very few people with that because we've not had these vaccines before. In terms of reproduction, so this is important to talk about this issue because there's been quite a rapid spread of disinformation around this issue globally through WhatsApp and other groups. The spread of misinformation and disinformation on social media spreads as rapidly as infection itself, and there's evidence that fake news travels faster than truth, which is itself interesting. But the idea that the vaccine is somehow harmful for future reproduction in human beings doesn't stand on any legs. There's no truth to that at all. There's no basis to that. However, in women who are pregnant, at the moment, it is recommended that women who are pregnant or planning to become pregnant or breastfeeding, that they can go ahead and be vaccinated. But it's acknowledged that women who were pregnant were excluded from the clinical trials in the same way that children were excluded from the clinical trials, and that there are trials now ongoing looking at safety and efficacy in those in women who are pregnant. So we will learn more as time goes on about safety in pregnancy. But there, again, as mentioned, biologically, the RNA vaccines themselves are inherently safe, fundamentally by design, and there's no strong reason to be concerned. If there are specific issues for individuals with their pregnancy, difficult to become pregnant, or at the extreme ages of pregnancy, or any complications of pregnancy, then of course people should speak with their medical practitioners and so on, and personalize their decision. And that's a general statement as well, that a public policy is public policy, but there's always going to be exceptions to any rule. And just like you speak to your local Orthodox rabbi on your own shaylas, you sometimes have to speak to your doctor on your own issues, even if the policy is that it is appropriate and safe for women who are pregnant to receive the vaccine.
Another one of the questions a few students have asked, like, and this highlights, I think, some nice impulses on the part of our students, asking about, wondering about something that you had mentioned in your own personal research and your practice in the past, the equity of wealthier countries like the United States getting, again, distribution has been slow, but the assumption is that by the end of the summer or towards the end of the year, people who want to get vaccinated will be able to get vaccinated. What about poorer countries that cannot afford it, as you had referenced earlier? How are we managing that? How do we, kind of responsibly consider the rest of the population that may not have access in the same way as wealthier, more affluent countries like the United States has?
Yeah, so the first thing to say is that the AstraZeneca vaccine is the only one of the vaccines that was produced at cost. It's going to be sold at cost. So it was designed as a not-for-profit vaccine and designed to be able to be delivered globally in the available refrigerated cold chain for vaccines globally. So there is a vaccine out there that does that. And it's been a bit confusing how well that vaccine works and what it does. And because of the questions around the trial, there's been some hiccups around that. But fundamentally, that was the aim of Oxford University and the company AstraZeneca. Nevertheless, the issue here really is that we need to be able to provide vaccines regardless of the ability to pay, both because it's the right thing to do, but also out of self-interest. You can't control a pandemic unless you control it everywhere, because it'll just resurge as it did from Wuhan, and within a matter of weeks was global. We need to deal with this as a global community. And to acknowledge that not everybody can afford things in the same way, and just because you can't afford doesn't mean you don't deserve. Having said that, the United States government invested billions and billions and billions of dollars in vaccine development. So, it's appropriate that that get reflected, for example, in the vaccine price that Americans have to pay, given that they've already paid with their tax dollars, compared to, let's say, in England or some other country of equivalent, or Canada or whatever, of equivalent financial standing, but that the taxpayers hadn't made that investment. That's also an argument from justice. But certainly in terms of the fundamental point of the question, which is regarding low and middle income countries, so there is a global facility, a global organization or arrangement called COVAX, which is an arrangement that's run by the WHO, the World Health Organization, together with Gavi, the Global Vaccine Fund, and with CEPI, the Coalition for Pandemic Preparedness and Innovation. And that basically is a financial mechanism whereby governments invest money in this process, and the World Bank and other development banks, in order to make the vaccine available. The plan is that by the end of this year, 2021, enough vaccine will be available to vaccinate 20% of every country's population, presumably those people who are at greatest risk, people, the health workers, the elderly, people with other medical conditions and so on, at least in the first instance. And once that happens, then as production ramps up, we can give to everybody else as well. That's the aim. And there will be a co-contribution or a payment that's probably going to be tiered according to capacity and ability to pay. But it's very important that global distributive justice principles are applied here. But at the same time also that we have to be realistic about what things cost to produce. I think that's probably sufficient for an answer for that.
Well, I want to thank you very much. This has really been extraordinary. I mean, there are probably another 25 questions that I'm not getting to, but the hour is late and we do have to end. And I might say at some point later in the year, perhaps we can hear again from Dr. BarZeev. I'm sure there'll be more developments over the next couple of months, and we'd love to be able to kind of hear from you again towards as news becomes available. I do want to really thank you for taking the busy schedule, taking the time out to meet with us. This is really very meaningful, both to hear about the science of it, raising the ethical questions, and pushing us to know more and to think more. I want to particularly thank Mr. Goodman and Ms. Brandress for coordinating this, and for both Kiki and Emmett, thank you for interviewing Dr. BarZeev. I also want to give a shout out to Gilad Karsh, who was part of the planning but could not make it today, and especially to all the students and staff who asked a lot of really interesting questions. It really is an honor to meet with you today, Dr. BarZeev. Thank you so much for talking with us, and we look forward to learning more and hopefully more of us being able to get access to that vaccine in the upcoming months. Thank you very much.
Okay, thanks for the very good questions and discussion. Thanks a lot. Bye-bye.